Welcome to K11 Software Solutions AI Assurance Playlist. This talk, Transforming Legacy Test Automation, a real-world AI integration journey using Ollama and local models, focuses on architectural decisions, integration challenges, and the lessons learned when bringing local AI into legacy automation systems. We're going to walk through a real-world case study of how one team managed to modernize a mature, battle-tested system, and they did it all without having to start from scratch.
So if you've worked in enterprise test automation, this situation probably sounds pretty familiar. You've got this reliable legacy framework that, gets the job done, but it's totally missing modern AI capabilities. This team's Java-based Selenium framework was stable, it was deeply integrated, but they really needed more intelligent assistance. And that led them to the classic strategic question: do you enhance what you already have, or do you tear it all down and start over? Well, they made the pragmatic choice to retrofit AI into their existing framework, building on years of stability instead of just throwing it all away.
Okay, so one of the very first and most critical decisions was how to implement AI. The team chose to build on local models using Ollama rather than relying on cloud-based APIs, and this choice was really driven by three key pillars. First and foremost, security. This is huge. By running models locally, sensitive test data never has to leave the company's environment. This gives you full control and makes it so much easier to align with strict enterprise security policies.
The second factor was cost. Think about it. With local models, there are zero per-request charges and absolutely no API quotas. This is a massive advantage for CI/CD pipelines that might be running thousands of tests. It makes large-scale AI assistance actually economically feasible.
And finally, we've got performance and reliability. A local setup means you have zero dependency on external network availability. You get much faster response times without latency, and the entire system can operate perfectly even in isolated or offline environments.
So how do you inject a powerful new technology like AI into a mature framework without causing total chaos? Well, the team used a really clean and elegant solution, the adapter design pattern. Let's dig into how that worked.
The beauty of this approach really lies in its simplicity. The team created a single LLM interface, which basically acts as a standard plug. The actual AI client can plug into it, but so can a simple fallback for when AI isn't available. This creates a really clean separation, and that prevents the new AI feature from ever breaking the old system. And this really shows you the amazing results of that clean architecture. There were zero, and I mean zero, breaking changes to any of the existing tests. Teams could adopt the new AI features gradually, and the built-in fallback modes guaranteed the framework remained just as reliable as it always was.
All right, so with the integration handled, the team could focus on the fun part, building tools to solve real problems. The first capability was designed to help engineers with one of the most common tasks in UI automation, finding stable element locators.
Just look at how effective this is. An engineer can simply describe an element in plain English, and boom, the AI returns three different, robust locator strategies. It even ranks them by reliability. This is a massive accelerator for day-to-day work.
The next capability they built was even more ambitious. They used the local AI to generate complete, runnable test cases from just a simple, high-level description of a user's scenario.
So the really crucial point here is the completeness of the output. For a prompt like user login functionality, the AI generates the entire test method. That includes setup, actions, and proper assertions with explicit waits. This turns a simple idea into working code in literally seconds. The final tool they built tackles what is often the most time-consuming part of test automation, and we all know what that is: debugging failures. This feature analyzes test failure logs and suggests actionable fixes.
And this is a fantastic example. For a common error like no such element exception, the AI doesn't just report the error back to you, it actually analyzes the context, lists probable causes like timing issues or UI changes, and provides specific code snippets for potential solutions. This just drastically reduces debugging time.
Of course, no real-world project is without its challenges. It wasn't all smooth sailing. And sharing these hurdles is just as important as sharing the successes, because this is often where the most valuable lessons are learned. A great example was their initial AI availability check. It was just too strict, and it was causing false negatives. They solved this by moving to a more flexible validation that simply checked for any meaningful content, which, in practice, proved to be far more robust.
They also had to fine-tune the CI/CD integration, which involved practical steps like caching models and implementing retry logic. Another hurdle was performance. I mean, initial AI response times of over 30 seconds were just unacceptable. So the team optimized them by tuning model parameters and running the calls asynchronously.
So after overcoming those hurdles and using the system for about 6 months, the team was able to actually measure the impact of their work. And honestly, the results kind of speak for themselves.
They recorded a 40% reduction in the time it took for developers to create new element locators. That's a huge daily win.
Even more impressive was the 60% reduction in time spent debugging those common and super frustrating element not found errors.
And on the business side of things, that decision to use local AI resulted in over $50,000 in annual savings compared to what it would have cost to use cloud-based services at the same scale.
This chart provides a really clear visual summary of the productivity wins. You can see significant improvements not just in creating locators and debugging, but also a solid 25% reduction in overall test maintenance cycles.
So what can other teams learn from this whole journey? Well, the team distilled their experience into a pretty straightforward playbook of best practices.
The playbook is really straightforward. The core advice: start small, always build in a fallback mode, and measure your impact. And just as importantly, avoid the pitfalls. Don't try to rewrite your entire framework or compromise on security. And always remember, the goal here is to use AI as a tool that guides expert decisions, not one that replaces them.
And that really brings us to the final, and I think most crucial takeaway. This journey shows us that the future of test automation isn't about replacing skilled engineers. It's about augmenting their expertise with intelligent tools, transforming even the most established legacy frameworks into powerful AI-assisted platforms.